Okay, in this segment we're looking at number 40 and 41. I'm not quite sure why 40 was frequently missed. It says, from the information in the diagram, can you prove that these two triangles are congruent? Not unless there was some error in the presentation of the problem. But anyways, when we look at this, what's given, we see that all three angles of one triangle are congruent to the other. And then segment DF is shared by both triangles, so it's congruent to itself. So angle, side, angle, angle, side, angle allows us to say that these two triangles are congruent. Remember the way that your congruence theorems and postulates are written, the way the acronyms are written, that's the pattern that you're looking for in the triangle. So I've got two angles and an included side in one triangle, congruent to two angles and an included side of another triangle. All right, the included side meaning it contains, it's part of both angles referred to. Number 41, can you use the angle-side-angle postulate and the angle-angle-side theorem to prove both of the triangles congruent? Hold on a second. Okay, somebody came into my room and I had to pause it. So where was I? Looking, based on what can we use the angle-side-angle and the angle-angle-side theorem? So I need to see what I can conclude from what's given. And I know, vertical angles are congruent. And so I have two angles in one triangle congruent to two angles in another triangle. So I could say by angle, angle, side, angle, angle, side, that these two triangles are congruent. But remember, if two angles in one triangle are congruent to two angles in another triangle, then that third pair of angles must also be congruent. So that allows me, knowing that, it allows me also to use angle, side, angle, angle, side, angle to show that these two triangles are congruent. So we can use both angle, side, angle, and angle, angle, side.